this is another question that I want to review in this little short video, like majority usually does it, trying to bring out some questions and not just looking at the questions. We are trying to analyze the options, so not just looking at the answer. So the video specifically is not just showing us the answer, but trying to know why the answer is that, and trying to look at some other points that we should know concerning this subject area. Now, all you have to do for you to come across videos like this is just subscribe and try and comment, and of course share the videos to your friends. Now, look at this question that I have here. A very simple, straightforward question, but all we want to do is we want to see how we can get some points from the questions. Now, it's a simple question if you are very good in chemistry, but if you are not, then join me. Let me show you why the answer is like that. So, what is the question? They said the allotrope of carbon used in the decolorization of sugar is dash. They said graphite, they said soot, they said charcoal, they said lampblack. Now, for you to know the answer to the question, first off, you need to recognize, yes, that carbon possesses allotropy. But it's not just carbon that has allotrope. There are some other elements that do possess allotropy. Now, what are these elements? For example, the element sulfur exhibits allotropy, where element exists in different forms but in the same physical state. Now, we have sulfur exhibit allotropy. Of course, we have carbon exhibiting allotropy. We have phosphorus exhibiting allotropy, where questions can come like this. There are two major allotropes of phosphorus, which we have the red phosphorus and of course the white phosphorus. Is the red phosphorus that is used to manufacture matches, while the white phosphorus is quite explosive and quite poisonous, and usually reacts easily with air, so it's stored underwater because it catches fire easily. Because why does it catch fire easily? It has a low ignition temperature. Now, what am I trying to do here? I'm trying to analyze and trying to see, apart from carbon, what other elements also exhibit allotropy. Now, there is a metal that exhibit allotropy. Now, allotropy is usually found between non-metals, but there's a particular metal that do exhibit allotropy. Now, what metal is that? That metal is tin. So they can ask you in the exam, they can say which of the following metal do exhibit what allotropy. Now, let's go back to our question. Now, they're trying to ask us that amongst the allotrope of carbon, which particular one is used in the decolorization of what? Of sugar. Now, there are some things that I want us to bring to our knowledge. So as you're preparing for an exam, it might not necessarily be the exact question, especially those of us preparing for post-UTME. It may not be the exact question, but if you get to study the questions very well, you might end up knowing the answers to other questions that can be set from this particular area of chemistry. Now, we have said that carbon exhibit allotropy. There are two um, crystalline forms of carbon. We have the diamond, of course, the graphite. So if I want to look at carbon as it were now, I can say that carbon exhibit two forms of allotropy. We have the crystalline allotropes of carbon, then we have the amorphous allotrope of carbon. Now, you need to stay with me. You need to look at small. Now, this crystalline, for something to be crystalline, it seems that the molecules or the atoms are orderly arranged in this kind of allotropes. Now, the common ones are the what? Diamond. Diamond now common allotrope of carbon, but now crystalline carbon. Then of course we have what? We have graphite. Now graphite is another one. Now this diamond and graphite, let me just throw some little points on them. Of course, diamond is very hard. So because of that, diamond is used as an abrasive. And while graphite is not hard, it's soft. It exhibits van der Waals force, unlike diamond that exhibits what? Covalent kind of bond. Now I've used this to tell you now that the kind of bond that exists in diamond is covalent bond. The kind of bond that exists in graphite is van der Waals, and of course van der Waals are weak forces. So that makes this graphite to be soft, commonly used as lubricant. Now there are other amorphous forms of carbon. What are the amorphous forms of carbon? It's under this place that we have the likes of coal, we have lampblack, like you can see in the option, we have soot, and of course we have what? Charcoal. Now we are beginning to approach the answer to the question, so we want to just analyze. Now this charcoal is under an amorphous allotrope of carbon. Now, this diamond and graphite is crystalline, but these guys are amorphous. When something is amorphous, simply means that it's non-crystalline. It's a non-crystalline allotrope of carbon. Now, let's come back to the main thing. Now, we'll look at the charcoal. Now, this charcoal is actually formed from incomplete combustion of carbons. That's why there are three types of charcoal. We have those ones that form from wood, so we have the wood charcoal. We have those ones that form from sugar, so we have sugar charcoal. We have those ones that form from burning of animals remains. So talk about what? Animal charcoal. Now remember, now these are the types of charcoal. Now I want to just bring this to your mind again. Now talking about this sugar charcoal is the purest form of amorphous carbon. Not just the purest form of charcoal, it's the purest form of amorphous carbon. The reason being that this sugar charcoal is actually formed from dehydration reaction. So when sugar reacts with concentrated H2SO4, that process is a dehydration process and usually called charring of carbon. Now, this sugar charcoal, like I rightfully said just now, is the purest form of amorphous carbon and it's actually formed from dehydration reaction. Now, amongst these allotropes or among this type of charcoal, which one of them? So that's what they're asking us now. The allotrope, of course, they you can already see the answer in the option here, that the answer here is what? Is charcoal. So the allotrope of carbon used in the decolorization of sugar. This word, this says statement, I need to underline it. We need to analyze it very, very well. Now, that statement is trying to tell us that during the preparation or manufacture of sugar, um, decolorization occur. Now, what is used as a decolorizer? We have stated it already that is charcoal that is used as a decolorizer. But there are three types of charcoal. What are they? The wood charcoal, the sugar charcoal, and of course the animal charcoal. Now, amongst these three types of charcoal, you will now begin to ask which one of them is commonly used as a decolorizer during the manufacture of what? Of sugar. Now, that charcoal is animal charcoal. Why? Because it's a good absorbent, so it can easily absorb color. Now, what sugar is usually decolorized when it's being prepared? Now, that is another point that you need to know. Let me take it like this. You know that we have monosaccharides, we have disaccharides. Now, the monosaccharide is under the space that you are having the glucose, the fructose, the galactose, the mannose, and the likes. Now, under disaccharide, that's where we're having the lactose, the maltose, the sucrose. Now, sucrose is regarded as brown sugar, and that is what we are referring to. So during the manufacture of sucrose, charcoal is used as the decolorizer. Now, what type of charcoal is commonly used as decolorizer is the what? Is the animal charcoal. Now, you can see the way we analyze these questions. Now, I have other questions for us to analyze again after this question. Now, that question is coming out from the aspect of the organic chemistry. So now you're seeing the way we brought out our answer, very sharp, straight to the point, no time to waste. Now look at the allotrope of carbon. Now, first of all, we started by listing some elements that exhibit allotropy aside from what? Carbon, and we decided to look at what allotrope is used as a decolorizer. We said it's charcoal, and what are the types of what? Of charcoal, and which of them is the purest type of charcoal. Now I get on that question when I want to bring common side so that we get to analyze that question very well, and it's from organic chemistry. Now let's see what that question is talking about.